Hello, ArtSciTech viewers. Today, we're embarking on a journey back to Earth's ancient times, perhaps one of its most captivating chapters, Pangaea. Pangaea was a colossal supercontinent that existed in prehistoric eras, uniting all the world's landmasses into one giant piece. But how did this supercontinent come to be? When did it exist? And how did it transform into the continents we recognize today? Come along as we uncover the answers to these questions and so much more together. Throughout this video, we'll dive into fascinating details about Pangaea's history, its formation, the movement of continents, and even what the future might hold. So, if you're ready, grab your tea or coffee. Let's get started. Pangaea's formation is deeply tied to the inner workings of our planet. The tectonic plates that form Earth's crust shift and move, driven by convection currents in the mantle below. During the Devonian period, these currents nudged the continents closer together, giving birth to Pangaea. In particular, the merging of the major plates that would later become Eurasia, Africa, and the Americas laid the groundwork for this supercontinent. Around 335 million years ago, it stood as a massive landmass. The entirety of Earth's land united into one. That's right. Every continent we know today was once part of this single enormous landmass. Scientists call it a supercontinent. As I've hinted, this was all thanks to tectonic movements. The plates in Earth's outer layer converged and fused, creating this vast landmass. And it didn't just shape the land of its time, it also had a profound impact on the evolutionary path of life on Earth. So how exactly did this supercontinent form and evolve? To get the full picture, let's take a quick look at Pangaea's timeline. When we peek into Pangaea's history, we see it began taking shape around the Devonian period, roughly 335 million years ago. It wasn't an overnight event. Pangaea formed gradually over time. During this period, continents started drifting closer together, inch by inch. It wasn't until about 300 million years ago, in the Carboniferous period, that Pangaea fully came together. This supercontinent reigned for about 100 million years. Then, around 175 million years ago, during the Triassic period, Pangaea started to split apart, breaking into separate continents. This breakup was powered by a process called plate tectonics. The coming together and drifting apart of continents is a slow, ongoing dance, one that began with Pangaea's fracture and continues shaping our world today. So, why did Pangaea break up? The answer lies in the restless movement of tectonic plates. These massive slabs covering Earth's surface are always on the move, shifting the continents along with them. Pangaea's breakup was a direct result of this motion. Take India, for example. Once part of a supercontinent called Gondwana, it gradually drifted toward Asia. That journey ended with a collision that birthed the Himalayas. Meanwhile, ridges in the middle of the Pacific Ocean played a big role in pulling continents apart. As they separated, oceans began to form in the gaps, reshaping the planet's surface. Pangaea's existence isn't just a theory. It's backed by tons of geological evidence and fossils. Fossils, for one, tell us the continents were once neighbors. Similar fossils pop up in Africa and South America, hinting they were joined long ago. Geologists also use paleomagnetism to confirm this. Magnetic minerals in rocks act like ancient compasses, recording Earth's magnetic field from way back when. The magnetic traces in rocks from Africa and South America match up, proving these continents were once one. Mountain ranges and rock formations offer more clues. The Appalachian Mountains, for instance, show similar rock patterns in both North America and Europe, a sign these lands were once connected. Thanks to evidence like this, geologists have pieced together Pangaea's story. Once Pangaea split, two major landmasses emerged, Laurasia and Gondwana. Laurasia covered the northern hemisphere, including North America, Europe, and Asia. Gondwana spanned the southern hemisphere, encompassing South America, Africa, Antarctica, Australia, and India. The breakup gained steam with the opening of the Atlantic Ocean. The North American and Eurasian plates drifted apart, kickstarting the process. Likewise, the South American and African plates split, breaking Gondwana apart. Mid-ocean ridges fueled these shifts. This separation didn't just reshape the land, it influenced evolution too. India's crash into Asia, for example, gave us the Himalayas. The drifting continents sculpted our oceans, seas, and mountains. Pangea's climate was a mixed bag. The inner regions were hot and dry, home to sprawling deserts. Closer to the coasts, things got milder, fostering different ecosystems. This variety let diverse plants and animals thrive across Pangea's regions. Life back then was bursting with variety. Dinosaurs ruled the land as the dominant species. Plus, the first mammals and birds made their debut during this time. The evolution of life on Earth hinged on Pangea's unique environmental quirks. To dig deeper, let's explore the cultural and geological traces it left behind. After Pangea fragmented, it reshaped human history, cultural growth, animal migrations, and biodiversity. Let's break it down with some examples. 1. Geological traces. Pangea's breakup was one of Earth's biggest landscape overhauls. The shifting continents, expanding oceans, and new sea routes unfolded over hundreds of millions of years, leaving behind key geological marks. Fossil traces. Before the split, animals and plants roamed freely across connected continents. Post-breakup, fossil studies reveal some species stuck to specific continents, like Mesozoic dinosaur fossils. Mountain formations. Pangea's breakup sparked the rise of mountain ranges. India smashing into Asia to form the Himalayas is a prime example. These events help us track continental shifts and crustal movements. Volcanic and seismic activity. As Pangea broke apart, massive volcanic eruptions and earthquakes rocked the crust. These forces helped continents settle into place, and some areas still feel the tremors today. Stay tuned. A video on volcanism is coming soon, so don't forget to follow. 2. Cultural traces. The splitting continents didn't just change geology, they shaped human history and culture too. The new divides guided early human migrations and cultural growth. Human migrations. After Pangea's breakup, early humans crossed continental barriers, settling across the globe and forming unique communities. Think migration routes from Asia to Australia or Europe to the Americas. Language and culture evolution. Isolated by geography, communities adapted to their surroundings, birthing distinct languages and cultures. Survival strategies became as unique as the lands they lived on. Spread of agriculture. The split led to agriculture popping up independently across continents, with techniques spreading and evolving. It's a window into how farming shaped societies and boosted trade. 3. Biological traces. Post-Pangea, animals and plants adapted to new homes. The continental divide drove biodiversity, with isolation sparking unique species. Take Australia. After splitting off early, it became a hotspot for exclusive species like kangaroos and koalas, evolving in isolation from the rest of the world. What about the future? Scientists say Pangaea might not be a one-time deal. As long as tectonic plates keep moving, continents could reunite. A future supercontinent dubbed Pangea Proxima might emerge millions of years from now. It'll take ages, but plate tectonics could pull it off, closing oceans, raising mountains, and reshaping the world once again. All right, friends, that's our deep dive into Pangaea and all its wonders. Pangaea isn't just a chapter in Earth's history, it's a key to understanding how our planet took shape. Future supercontinents, tectonic shifts, and continental evolution make this story endlessly intriguing. Want to learn more about Pangea's past? Don't forget to follow us. Catch you in the next video. Make sure to subscribe. Take care and keep exploring with science.